recommend using your calculator. So I know everybody wants to know the precise geometric definition of a hyperbola. Sure, we care about that. And then we're going to get into actually drawing the graphs here today. So very similar to an ellipse. I know everybody's like, why do we have to do these foci? Technically, those are really what generate your hyperbola in this case. If you take, of course, any point on the hyperbola, mine are in red, of course, no color copy machines for you, and you, of course, calculate the distance to each focus point. If you subtract that, you will always get the same number. So even if I picked a point over here on the hyperbola, did the distance to the focus, subtract it, it would equal out the same thing. That is technically how a hyperbola is generated. Does that really affect how we're going to draw them? Probably a whole lot. Okay, now, a lot of stuff on here. Don't get crazy. You're going to mark it out, like I said, very similarly to an ellipse to start with. Notice you're going to have those perfect squares in the bottom. Whatever letter it's under, that's which direction you go. One big difference. Ellipses always start with x. Our hyperbolas do not necessarily. If the variable that's first is x, that's how you know it's horizontal. If y is first, then it opens vertically, up and down. So it does make a big difference today on which variable comes first, but to me that's kind of common sense. Now, transverse axis. You're going to tell me, sounds very fancy, the length of the transverse axis. That is the axis that connects the vertices of each of your hyperbolas. So you've got your left one and your right one. So I would just want that total distance there. You can count it really if you have to. Same thing, transverse axis on this guy is the length that connects the two vertices. Okay, you can count it, etc. Now, foci equation, we talked about those on the board. It's going to be a plus. And one other thing we're going to have today, of course mine are in blue, yours are not, these lovely blue dashed lines, of course, are asymptotes. We've seen asymptotes before. They're lines we're not going to cross or touch. They kind of determine how wide our hyperbola is. Now, as far as the equations of the asymptotes go, all I'm going to ask from you is to give me the slope. Well, we can all do slope, rise over run. Think about some old school 8th grade math. So, just kind of a little general how I'm going to do this. So I'm going to kind of start just like I do on an ellipse. I'm going to find the center, I'm going to count left and right, up and down, the whole 9 yards, just like you would on an ellipse. But I'm not going to draw an oval. I'm going to sketch what we call the central box. The central box then lets me draw the asymptotes. The asymptotes let me draw the hyperbola, because that's going to determine how wide they are. And then we can sketch everything from there. So here we go. Now, notice on the top, x squared, y squared, there's no numbers with them. So your center's at 0, 0. Eventually we won't be at 0, 0. And I start plotting it just like I would an ellipse. 9's under x, square root of 9, 3, 3 right, 3 left. 16's under y squared, square root of 16, 4, 4 up, 4 down. Now, if that had a plus in between the fractions, we'd draw the ellipse, and there we go. But we don't. We have a minus. So to make it into a hyperbola, now you're going to draw your central box around the outside of those 4 points. And I'm just going to draw my dash, because it's really not part of the hyperbola. They're dotted. The purpose of the central box is now you can draw the asymptotes. The asymptotes go from the center to each corner. And again, technically not part of it. It's just going to let me know how wide to draw it. Now, I am ready to draw this thing. First things first, I'm going to check which variable comes first. In our case, it's x. So it's going to open horizontally. So I'm going to find the right, which I guess when he dashed lines here, this right point, which was right here on the box, which I have so many green dash points here going, and I'm going to draw close to my asymptotes. I'm not going to cross or touch. So one of my vertices is at 3, 0. And then I take the left point on my central box, which kind of got buried here with all my dashes and whatnot, which was at negative 3, 0, and I draw close to my asymptotes. I do not cross or touch. I should have left a longer blank here, I guess. Now, length of the transverse axis is the length between your two vertices. So since it's horizontal between our two vertices, 3 and 3, 6. I will do the foci in a minute. Now, asymptotes. A couple ways you can do it. One, there's two of them. The one that rises, the one that falls. So I just want the slope, remember. So I'm just going to get fancy, put M equals. Since there's two lines, one rises, one falls. Now, you can go old school and just count rise over run. So if you want to do that, I start at the center, and you can count to any corner on your central box. I don't know why, I just always do the top right one, maybe because I'm right-handed, I don't know. So I'm going to go up, of course, 4 over 3. I can also get that from the equation. Remember, y is the rise, or x is the run, 3. So I can also tell from the equation if it gets kind of messy over there about my asymptotes and everything else. Now, last thing, of course, foci. We've got to do the darn foci, the c squared. But this time you have minus in your standard form, so you need the opposite. You're going to add the denominators. Well, that's kind of nice, 25. And when we root it, we get plus or minus 5. And again, just like on a parabola, the foci need to be inside these hyperbolas. So I'm going to go right 5, left 5. And I'm just going to jot those ordered pairs down. I'm at 5, 0, and negative 5, 0. You can put plus or minus if you want. And that's basically what you're doing today. The only thing that's going to change, we might have square root for C, and you might eventually not have the center be at the origin. That's what we're doing. I kind of like these. And a therapeutic. Okay, not in the form, but not a big deal. Okay, remember, I didn't lie to you. You don't have to complete the square today. I did tell you that. But we do have to do a little bit of work to get it in the form. Big thing is we need to be set equal to 1. Well, we can do that easily enough. I'm just going to divide everything by what? Yeah, 144. So wear my taller shoes today. All right, 9 over 144, what does that reduce to? You got it. I'm just not going to write the 1. I'm just going to jot it down here so I don't make a mess out of it. 16 goes into 144. 9. Got it. Okay, no numbers with x and y, so our center's still 0, 0. Eventually, we'll get away from the origin. So let's mark that first, 0, 0. Same deal, just like you would mark an ellipse. Square root of 16, 4. Right 4, left 4, since that's under x. Okay, 9 under y, up 3, down 3. Of course, if it was an ellipse, we'd draw the old one, call it good. But we need to draw our central box, which goes around the outside here. Purpose of the central box is now you can draw the asymptotes. They go from the center to each corner. And then to determine whether it's horizontal or vertical, you just look to see which variable we have first. Again, we will do a vertical one, but again, we have a horizontal one. So I'm just going to take this right point on the box, close to the asymptotes. And that vertex here, I'm at 4, 0. I'm going to go ahead and jot that one down. 4, 0. And then my left point, negative 4, 0. I'm just going to put plus or minus, because I don't have a very long length there. All right, let's give the length of the transverse axis. How wide? How across? How many units? 8, 4, and 4. Let's do the asymptotes. Now, this time, I'm not even going to look at the graph. I'm going to do it off the equation. Rise over run. Y over x. 3 over 4. 4, of course, you can count it, up 3 over 4. And foci c squared again. So we're going to add, this time, our denominators. So I'm adding, again, we have 25, square root of 25, 5. And I'm just going to jot those points down. I'm going to put plus or minus for it, make it easy. Got it. Any questions on that? And again, if you want to check it in your calculator, obviously those equations are in there. You can type in like the denominators and whatnot. It'll draw the curves, but other than that, it's not very helpful. It's not going to draw the foci on. It won't have the asymptotes. It won't have the central box. But if you're worried about just kind of the general shape of the graph, it will help you with that. Okay, same thing, not in standard form. I don't have to complete the square though, so we're not going to panic about that. I do know it needs to be set equal to 1. That's an issue. I also don't like the fact there's that plus 9 on the left. Just the variable should be on the left. So first thing I'm going to do, let's just subtract 9 off. Because I just want the variables over here on my left side. Now I'm going to set it to 1. I'm being conscientious in my signs too. Now we usually don't leave a negative in the denominator. When we have a fraction, we'll kick that out front. 2 negatives in the middle, I'm going to make it plus. For dramatic emphasis, I'm going to put over 1. You don't have to have the over 1. And I still don't love that. Why do I say that? The minus needs to be where? In the middle. So I'm just going to do a switcheroo. And that's a critical detail because technically y should be first, so it opens how? Up and down. So that's why we got to be conscientious. Still no numbers on the top, so we're still at 0, 0 for the center. I promise we'll eventually do one that's not at 0, 0. I'm going to mark it out the same as always. 1 under y, square root of 1, 1, up, down, 1 unit. 9 under x, so right 3, left 3. And of course, for our hyperbolas, we're going to draw our central box. I'm going to draw my asymptotes from the center to each corner. Got so many dashed lines on here. And this time it opens vertically because y being first. So I'm going to take this top point that was on my central box, kind of got buried there in all my green dash stuff. So that vertex, I'm at 0, 1. Let's go ahead and list that guy. And then my bottom point there, 0, negative 1. Or you can put plus or minus 1. I don't care. Now, transverse axis. Remember, the transverse axis connects the vertices. So it's the vertical one. So from the top to the bottom, 2. Slope of my asymptotes. You can do it off the graph. I'm going to get fancy and go equation. Rise over run. Y over x. So is it 3 over 1 or 1 over 3? 3 over 1 or 1 over 3? Rise over run. 1 over 3. Y, x. And of course, you can old school count it. Up 1 over 3 if you want to. All right, foci, of course. Our c squared. This time, of course, we're going to add them. 1 plus 9. And let's root it. Now, for me to graph that, square root of 10 isn't very helpful. I punched that in my calculator earlier. The square root of 10, I got to take a look here. Square root of 10 is about 3.2. And remember, the foci are inside the hyperbola, just like they're inside of a parabola. So up 3.2, good enough. Close enough. Okay, so foci, we went up and down. So from our center, which was still 0, we went up a square root of 10 and down a square root of 10. So I'm just going to put plus or minus. Because you want those exact answers. I don't want the 3.2 version. What do you think? Not too shabby to draw? This is what it is. It's not too crazy today. Now, you're like, why are we even doing it anymore? We got it. And you probably do. But due diligence. Let's do some where we're not at 0, 0 for the center. So again, now you're going to have that h and k on the top, just like circles, parabolas, ellipses, all the figures. You have to switch the signs in parentheses. So here we go. So notice I put a center blank on this guy. So again, now you've got your values with x and y. So I'm going to switch the signs. +1, -2. That's the only new exciting part to this problem. Ooh, okay. Plot 1, -2. Everything else is the same. 4 is under x. Square root of 4, 2. 2 right, 2 left. From our center. 1 is under y. Square root of 1, 1. Up 1, down 1. From the center. Okay, central box. Purpose of the central box. Now you can draw the asymptotes. So many dashed lines here. And how is this one going to open? side to side, left to right. I hear side to side, left to right, however you want to say it, because X is first. So my right point there on the central box, close to my asymptotes. Oh man, I kind of touched that one. Oh well, just blame my poor drawing skills. Okay, I'm going to jot down the ordered pair. It looks like I'm at 3, -2. And then I'm going to do my left point over here. And this guy I'm at -1, -2. Clearly, I should have put a longer blank for that, but that's all right. Okay, other things, let's do our length of the transverse axis, so connecting your two vertices. Well, we went left 2, right 2, so a total of 4. Slope of our asymptotes, you can count, rise over run, or just look at my equation, rise under y, 1/2. And let's do the foci, c squared. And of course, remember, subtraction in the formula, so you need the opposite sign. I'm going to do addition. So I'm going to do 4 + 1. Square root that. And that, we've seen it a lot, about 2.2. So I'm going to count from the center, right 2.2. Ooh, that's close. And left 2.2. Now, here's the tricky part of the day. I need exact coordinates for the foci. Okay, I like it. So we, of course, counted our foci from the center. Since we went left and right, we're putting that √5 on X, left and right. Y stays as Y. That's the only, I can't even really say that's the trickiest thing you gotta do today, but that's really not that bad, okay? Any questions on that guy? All right, let's do this last graph, my friends. All right, same deal. Center, not at 0, 0. I know, super exciting. Okay, careful on your signs and your order. What's the center?
-1, 2, 3.
Perfect. So switch the signs. Make sure X goes in the X spot. Same with Y. Very easy to just flip those. -1, -3. And I just start marking out same old way I do an ellipse. Okay, 16, square root of 16, 4. That's under Y, up 4, down 4. 25 under X, square root of 25, 5. Left, right, 5. Draw your central box. Now the asymptotes from the center to each corner. And which way does this one open? Horizontal or vertical? Vertical, because Y is first. So I kind of was losing my point there. There it is. So much stuff here on my smart board. So this ordered pair of the vertex, let's see, from the origin, I'm left up, so -1, +1. And then the bottom one, I'm right here. I'm at -1, 1, 2, 3, 4, 5, 6, 7. Length of the transverse axis. Let me get this drawn on here first. So what's the length that connects the vertices? 8. You went up 4, down 4, so 8. Let's do the asymptotes. From the equation, is it 4/5 or 5/4? 4/5. Rise, Y, rise first. And last but not least, that's our foci. C squared. Minus in the equation means we add them. Oh man, 16 plus 25, 41. I just kind of, because of course that's not going to root out nice. Why would it? And I did punch that in my calculator earlier. That's one I don't know. That's not a super common one. That, of course, is about 6.4. So from your center, I'm going to put those inside my green hyperbola, up 6.4, down 6.4. Close enough? Close enough. Okay, tricky part of the day. I need exact foci. So the question you have to ask yourself, are you putting that square root of 41 on the X coordinate of the center or the Y? Y, because you went up and down. So x is just chilling as is. On that negative 3, we're going to put our square root of 41. Got it. That's the only tricky thing of today. Any questions on that? Okay, so most of your equations are in standard form, so you might have to divide and set it to 1. That's as bad as it gets. And of course, I did